So the heat flow basically is actually calculated depending on two basic principles. Uh, Always the heat whichever is flowing, it flows from a higher temperature to the lower temperature. And the other important thing is a quantity of heat in a body is proportional to its mass and the temperature. And there is this law which says Fourier's heat conduction law. So, does anyone know what is Fourier's heat conduction law of heat conduction? Fourier. Fourier's
Heat
law
conduction collision.
of heat conduction. So, Fourier's law of heat conduction states that the heat flow across an area, heat flow across an area is proportional to the area and to the rate of change of temperature with respect to with respect to the distance normal to the area. So if you think logically, this is quite obvious. I mean, whatever heat is flowing across given surface, so that heat flow will actually be proportional to whatever cross-sectional area it has. And the other thing is the distance of it. Sonal, you have any problem?
No, sir. Sorry, sir.
So let's make a mathematical statement out of it. So we'll first of all define the notations that we'll be using in this. So Q is nothing but the quantity of heat, or simply heat, I'll say. Heat, the unit for this, calories per second. And then X will denote the distance, capital T will denote the temperature. So the Fourier's law of heat conduction states that the heat will be directly proportional to the area, say I'll call it capital A, into the rate of change of temperature with respect to the distance normal to the area. So dt by dx. Now the proportionality constant will give minus k into A into dt by dx. Okay, so this is the mathematical statement for Fourier's law of heat conduction. Now, whatever surface through which your heat is flowing. This A represents the area of that surface. So in this particular topic, we will be generally studying the heat flow across a pipe. So we have a pipe. Inside the pipe, what we have is we have a steam passing through this pipe. And we will have some temperature inside this. Outside is some temperature, room temperature outside this pipe. Inside the pipe, there is a steam which will have some temperature T1, T2, whatever. So it will have some distance from the center to the outer covering. From center to the inner covering, it will have something. So whatever heat is going to flow through this, it will be through the surface of this pipe. Okay. And when I want to calculate the heat flow, what I will have to do is I will have to take this area. What will be the modification in this? Q will be equal to, what is the area for this pipe? This is a cylinder, right? So it looks like a cylinder. What is the cross-sectional area for a cylinder?
Pi r square.
What is it? Are you sure? Pi r square?
So pi r L.
Pi r L or 2 pi r L? Okay.
Sir,
So
cross section area or
cross-sectional area will be?
sir, cross section area will be pi r square, but surface area is 2 pi r.
Curved surface area is 2 pi r.
Surface area is 2 pi r L, right? So where this L will represent the length of the pipe. Okay, length of pipe into dt by dx. Now what was x? X is the distance from the center, right? Now this is going to be variable. Like say if this pipe is having inner diameter as inner radius is 5, outer radius is 10. So this distance here will be 5. Okay. So if I look at the heat flow at the temperature at say at the center of this two circles, so midway somewhere, then that is going to be 7.5. Okay. Uh, so this distance varies from 5 to 10. Okay. So this is going to be the distance. So what modification I will do is whenever I want to find the uh, heat flow from a pipe, and in that case, our formula will become 2 pi x into L dt by dx. Moreover, if I calculate the heat flow from 1 centimeter long pipe, so 1 centimeter long pipe, the pipe is 1 centimeter, then this L will become 1, and my formula becomes Q is equal to minus 2 pi x into K dt by dx. Okay, so this is the formula that we'll be using. I will write it down here. So if you want the simplification, you can 2 pi x into K dt by dx. So this is the formula in every example we'll be using. You have to memorize this formula for the heat flow. Whenever I want to find a heat flow through a pipe which is carrying some steam, where K represents the thermal conductivity of the covering of the covering of that pipe. Okay, and moreover the minus sign is because as the distance will increase, the temperature is going to decrease, and so there we have minus sign. So in every example we'll be using this. Okay, fine. If you have any difficulty up to this, you can ask, or I will go for example now. Fine. Think no one has any difficulty here. Example. All the examples are on the same line. Okay. Some parallel examples are there. A steam pipe 20 centimeter in diameter. Steam pipe 20 centimeter in diameter. Protected protected with a covering with a covering 6 centimeter thick. 6 centimeter thick. With the coefficient of thermal conductivity with coefficient of thermal conductivity coefficient of thermal conductivity K is equal to 0.003 calories per centimeter degree second. Find the heat loss. Find heat loss per hour through meter long pipe. Through meter long pipe. If the surface pipe, if the surface of the pipe is at 200 degrees Celsius and outer surface outer surface at 30 degrees Celsius. So inner surface is at 200 degrees Celsius. So whatever steam the pipe is carrying, it is at 200 degrees Celsius. The outer surface is at 30 degrees Celsius. The inner pipe is having diameter of 20 centimeter, and that 20 centimeter diameter pipe is covered with 6 centimeter thick material, which is having thermal conductivity this. And what we need to calculate here is I need to find the heat lost per hour. Look, not second, just per hour. And the second thing is through a meter long pipe, not 1 centimeter long pipe. Okay, so let's just draw the diagram first of all in order to understand this better. Okay, so we have a pipe here. This pipe, this distance is going to be 10. Diameter is 20, so this is going to be 10. Then from this to this, it is going to be 16. Okay, so inner temperature 200 degrees Celsius, outer temperature 30 degrees Celsius. Okay, by Fourier's law, by Fourier's law, what we will have, Q is equal to minus K 2 pi x dt by dx. Look, remember that the heat flow, this is a constant number. Okay. So considering this constant, K is a constant, 2 pi is a constant. How can we solve this? Is equal to minus 2 pi K into dt. How can we solve this differential equation?
So how is that 16, sir?
How is that?
16.
Where is 60? There is a covering of 6 centimeter. Na? So the pipe is having diameter 20. So radius is going to be 10.
Okay,
And
sir.
there is a
Yes.
covering of 6. So 10 plus 6. The outer radius will be 16. Now my question is, how can we solve this differential equation?
Integration,
सर एरिया इक्वल टू 2 पाई एक्स सर ये थोड़ा सा
ये मैं एक 1 सेंटीमीटर लॉन्ग पाइप कंसिडर कर रहा हूँ.
अच्छा ठीक है सर ओके
हाँ, right now I am considering 1 centimeter long pipe to make my formula easier. Okay.
ओके
Later, whatever is the length, I will multiply. So now answer my question. How can we solve this? It is easy. I don't think it's
रिवर्स करना होगा रिवर्स
Integration
करना
both side.
reverse करना है. क्यों?
यस तभी सर एक्स और dx का इंटीग्रेशन होगा लॉग में
Which form it is? Umed,
Yes, sir.
how can we solve this?
Sir, we can directly integrate, but I am confused about what to do about this Q.
Q is a
Rest
constant.
everything
Q is
Q is
constant.
then
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 this
we
is,
can directly integrate, I guess.
so this is variable separable form, exactly. So Q is a constant. You can see that 2 pi K is a constant. So variables are x and t, both are separated, so I can directly integrate.
Yes, sir. Thank you.
Now, what is x? X, we saw that it is a distance, okay, along the normal. So x is running from, so your heat is going to start flowing from this surface, inner diameter, right? And it will go to the outer diameter. So x will be running from 10 to 16. Okay. What will be the temperature at distance
30 to 200
30 to 200 or 200 to 30?
200 to
Look, whatever limits you give on the left hand side, like 10 to 16. So at 10, our temperature is 200. So this is 200. And it will go to the temperature 30 degrees Celsius. So now we can solve this. So Q log of 16 by 10. So that will be log 16 minus log 10. And so I have directly combined that step. So minus 2 pi, the value of K is given 0.003. So integration of dt is t. So this will be 30 minus 200. So Q is equal to 2 pi 0.003 200 minus 30, this will be 170. Both minus sign get cancelled out on log 16 by 10, which is log of 1.6. What is the answer now?
15.705.
It is
15.705.
15.705. Which log you have used? Log to the base e or log to the base 10?
So to the base 10.
No, don't use log to the base 10.
Sir, 6.81.
6.81.
81.
Just a minute. What will be the unit?
Calorie, sir.
Per
Calories per
hour.
second.
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 This is calories per second. So in 1 second, this much heat is, flowing. So what is to be calculated per hour? Okay. So capital Q will be 6.81 into this will be per minute per hour from a meter long pipe. We have considered this from 1 centimeter. So I will have to also multiply by 100 centimeters. So what will be the value now?
So 24 lakh 51,600.
2.4 into 10 power 6.
2, 4, 5, 4, 4, 3.3861. This is much calories per hour from 1 meter long pipe. Okay, so this is how we are using definite integral. In some books, this can be done by some other way by adding an integrating constant. You may find it somewhere, but I'll suggest that you stick to this method where you are using the definite integrals. Clear?
Sir, which base log we have to use?
Log to the base e, ln. When you are using your calci, press ln, not a log. Am I clear?
Yes, sir.
Yeah. Next question. So I won't give all the details now. I'll write down the question uh, in short form. So inner diameter is 10 centimeters. Outer diameter (20 centimeters). Inner temperature at 200 degrees Celsius. Outer temperature is 50 degrees Celsius. Thermal conductivity, the value of K
Sir,
is, yes,
sir, why don't we convert Celsius into Kelvin, as Kelvin is the SI unit?
I don't convert because all the questions are in this form. Okay, so whatever prescribed books we are using, so in all of those books, our units are according to this. That's why I'm not converting to Kelvin and meter, so on, MPS unit, and that's why I'm not using. Okay,
Yes, sir.
0.12. So how much heat is lost per minute? Lost per minute from 20 meter long pipe. From 20 meter long pipe. Find the temperature at x is equal to 7.5 centimeters. From center of the pipe. From center of pipe. Let's draw the diagram. So this much distance is, inner diameter is 10 centimeters. So this one will be 5. Outer diameter is given to be 20 centimeters. So covering has to be of how much centimeters? Covering need to be 5 centimeters. Then temperatures are given to us, so we want to go for it directly by Fourier's heat law. So what we have is Q is equal to minus 2 pi K into X dt by dx. So Q into dx upon x is equal to minus 2 pi K dt. Integrating on both the sides, being variable separable form, the limits are going to be, covering is 5, so total distance will be 10, sorry. So integration will go from 5 to 10. At the distance 5 units, our temperature is 200, and at distance 10 units, our temperature is 50. So integrating, what do we get? Q log 10 by 5, which is 2, is equal to minus 2 pi K 50 minus 100, so that will be 50 minus 200 plus 150. What's the value of Q, anyone?
163.2.
163.2.
Yes, sir. 163.82.
163.
63.11.
163.82. Okay. Look, this much is a heat, flowing per second. Okay. Our question is how much it is lost per minute from 20 meter long pipe. So in order to find that value, capital Q, I will multiply 163.82 into 100, 1 meter
into 20.
into 20 into 1 minute. So that will be 60. So whatever the answer is, I won't go for this. I'll leave it for you. You can write it down in your notebook. But I will talk about the other thing now. What is the other thing? We are asked find the temperature at 7.5 centimeters from center of the pipe. So how can we do this? Can anyone try at least? This is Q, that is something which you have. Make a use of it and tell me how can we actually calculate the temperature at 7.5 centimeters.
So in the equation in which we integrated,
Hmm.
we can change the limits of x
from
Yes.
from 5 to till 7.5, I guess. And then we can also change the limits for the temperature, starting from the inner temperature till X, the value which we want to know.
Yes,
And then
exactly.
we can integrate and we can find the value of X, the
Yes,
temperature.
exactly. So the way we are going to make a change here is, so x is equal to 5. What is the temperature? T1 is 200. Okay. When x is equal to 7.5, say T is equal to T2. Okay. This is the T2 that we need to find. So I'll rub the diagram now and I'll do the integration. So we have now we have Q. So this will be 163.82 into dx upon x is equal to minus 2 pi k integral dt. Let's put the values. Now 5 to 7.5. The temperature at 5 is 200 and at 7.5 is say T2. We need to find T2. So let's solve it for T2. 163.82. This will be log of 2.5 divided by 5 is equal to minus 2 pi k into T2 minus 200.
So
So how is it?
112.34.
So T2 is,
112.34.
so this can be solved, and 112.34 degrees Celsius. So this is the temperature at the distance 7.5 units from the center of the pipe.
So how is it 2.5 upon 5 log?
Now what is integration of dx upon x?
Log x.
Log x. So when you put the upper limit,
7.5 upon 5, no?
7.5 upon 5.
7.5.
yes,
Yes, that's it.
yes,
Yes.
7.5 upon 5. Thank you. Fine. I'll give you one example which you can try. Sumedh, take care.
हेलो यस
Yes.
सर
आवाज तुम्हारे माइक से थी?
नहीं सर
Okay. So I'll give you the details. Inner diameter 10 centimeter. Five centimeter thick covering. With thermal conductivity 0.0006. Inner temperature 100 degrees Celsius. Outer temperature 30 degrees Celsius. Amount of heat lost per hour. Find heat loss per hour from meter long pipe. Yes, tell me.
Sir, one doubt, sir.
Yes.
I have a doubt in the previous question.
Huh.
Sir, there when we were finding the capital Q,
Huh.
so we whatever value we got, we multiplied that to like convert into centimeters, like 100 into 220. Why did we multiply by 60?
Because the question was we need to calculate heat lost per minute.
Okay.
Huh.
Okay.
Yes, do this.
Sir, is the answer 233.64?
No. Have you found out the final answer?
Yes, sir. 233.
Find out the final answer. Calories per hour from a meter long pipe.
So is the answer 197633.48?
1973
633.48.
663. Is it so? What actually?
Sir, I'm asking you, is it the right answer?
So what I have is this 1440 calories per hour.
Yes, sir. The answer comes close. 137058.
Sir, if 5 centimeter is the outer diameter, then while calculation we are getting a negative Q value,
5
right?
centimeter thick covering is not the outer diameter. So inner diameter is 10. So जो pipe है, this distance is going to be 5 और इसके ऊपर covering कितना दिया है 5 centimeter thick. This is 5. So total from here to the outer covering will be 10. So while integrating, you should go from 5 to 10. Am I clear?
Yes, sir.
Fine. That's all for heat flow. Our first